Hey guys, this is notes number 5. Okay, we're going to be going through graph analysis again, but through the perspective of a calculator. Okay, so before you guys do anything, make sure that you have your graphing calculator out in front of you. Okay, I kind of, for this lesson, I kind of discourage using Desmos or any other type of computational device. Try to use just your graphing calculator here because in the event that we are to take this exam in person, you guys need to be well versed in your calculator there, okay? Okay, so once you have your calculator and the packet out, okay, and I should have sent you a link. Let me know if I didn't. We're ready to get started, okay? So first thing, what I want you guys to do is to go ahead and write all of this out one more time. And again, we want to do this as many times so that it sticks. Okay, so I want you guys to go ahead and write this down. Pause, take as much time as you need. Don't use your notes. And then press play when you're ready. Okay? All right, here we go. So we'll move through this quickly since this is not the first time that you guys have seen this. We know that f is increasing whenever the derivative is positive, and you guys want to say this out loud too, okay? F is decreasing whenever the derivative is less than 0 or negative. If f prime changes from positive to negative, then you know that f has a local or relative max. Okay, I like to use the word local, it's shorter. Okay, f prime changes from negative to positive, then you're going from decreasing to increasing, so that means f has a local minimum. We call that the first derivative test. Okay, aka the sign chart. Okay, so then we step into concavity. We know that a function is concave up whenever f prime is increasing in value. And I know that f is concave down whenever f prime is decreasing in value. But when something is increasing, its derivative is positive. So if f prime is increasing, then f double prime should be positive. If f prime is decreasing, then f double prime should be negative. Okay, try not to mix these up. So we know that f has a point of inflection whenever, by definition, f changes concavity. When concavity changes. Now f prime will change directions. That will imply that f has a point of inflection. And f has a point of inflection when f double prime changes signs. Going from positive to negative or negative to positive, that'll imply that f will have a point of inflection whenever f double prime changes signs. Okay? So there you have it. You guys have this in front of you. Hopefully you didn't have to refer back to your notes that much. If you did, that's fine, but keep practicing, okay? So the following here in your tiny little packet, okay, it's not too many. These are AP released calculator questions specifically based on graph analysis, okay? These are what I consider the easy points because the calculator does all the work for you, okay? What you have to understand is you have to tell the calculator what to do. So as long as you know how to do that, as long as you know what you're looking for, you're going to be just fine, okay? So first, just to make sure that we're all on the same page, go ahead and turn on your calculator there. Okay? And what I want you guys to do is I want you to reset it. So I want you guys to go ahead and press second plus 712. Go ahead and do that. Second plus 712. You should say that RAM is cleared on your calculator. This is just to make sure that everyone is on the same page, okay? Cool. So here we go. Once you have that ready, let's do some problems. Here is number 85. Now, there is an 85, at least 85 problems on the exam, okay? They separate the numbers. I think the calculator questions start at like number 65 or 70, something like that. But that's just to imply that this is a calculator question, okay? Okay, so here we go. If the derivative of f is given by f prime of x, at which of the following values of x does f have a relative maximum value? So the buzzwords here are relative max, okay? Now, if you take a look, you want to think about which hat you're wearing, okay? We talked about that in the previous lesson. You're only going to speak the language that's provided to you. So here, they provided us the f prime hat. So that is the only language that you're going to speak, okay? So they want to know where f has a relative or local max. So if you take a look back, f is going to have a local max whenever f prime changes from positive to negative, okay? So here we go. First thing you're going to do, you're going to go to y equals, okay? Do this with me. You're going to type out the derivative function, which is e to the x. E is somewhere near at the bottom where natural log is, but you have to press second, then natural log. That'll give you e to the x. Make sure you jump down from the exponent, minus 3x squared. Okay? Now, just a few things. If you click on window, which is the second button right here, okay? You'll notice that the x min and max goes from negative 10 to positive 10. And the same thing with y min and y max. It goes from negative 10 to 10. This is your window that tells you how wide your graph is going to be. So you can go ahead and click on graph now. And just to make sure we're on the same page, you have something that looks like, oh gosh, something like this maybe. Okay, give or take. Okay, so take a look. We know that a relative max, a local max, is when the derivative, which is our graph, you guys, changes from positive to negative. Okay? So where does the derivative change from positive to negative, right? So let me give you just a pointer here. So let's say right here, that point, since this is the derivative graph, that point has a negative value. So does this point right here. So does this point. So does this point. And so does that point. Anything below the x-axis, the derivative will come out negative. So same thing over here. All of these values that are below the x-axis will yield some negative derivative value. Okay? Now, anything above the x-axis for this derivative graph will be positive. Okay, then we're not going to do this every time, but this is just for illustration. So where does the derivative change from positive to negative, right? So if you notice, the derivative changes from negative to positive right here and right here. Okay, but we're looking for where the derivative changes from positive to negative, which is that yellow highlight right there. Notice how it intersects the x-axis at this value, and we're not really sure what that is. Okay, so there's a name for that. We call that a 0. Okay, so first you have to know how to identify which 0 you're looking for here. So what you're going to do, so right now on your screen you should have the graph. Okay, right above the trace button says calculate. So you're going to press second and trace. This is pretty much your go-to every single time. Okay, so do this with me. We're going to press second, second, and then trace. And then it should give you a menu of options here. We're looking for a 0. So you can toggle down to where it says 0, or you can just simply press the number 2. Okay? So if you toggle down, you're just going to press enter when you get to 2, or you're just going to press 2 to make it quicker. Okay? Now, they're going to ask you 3 questions. Okay? So before you guys press anything, let's talk about it first. They're going to ask you, what is the left bound? What is the right bound? And to guess. Okay, so here's the thing. You have to pick a safe left value and a safe right value, okay? If I had to guess where that 0 is, it looks like it's somewhere close to where x equals 1. Something really close to 1. Okay? So I'm going to pick a safe number to the left and a safe number to the right. Now, you can toggle, you can move the left and right arrow. I think it's just easier to press a number. Okay? So a safe number to the left of 1 would be 0. So I'm going to press 0, then enter. Then they're going to ask you, what's the right bound? I'm going to pick a safe number to the right. I'm going to pick either 2 or even 3 here, okay? So I'm going to pick 3. You guys can go ahead and pick 2. If you guys take a look at your picture now, they draw a vertical line, okay? 2 vertical lines. Now, you might not see the first vertical line because it overlaps perfectly on the y-axis here. But before you guess, you want to make sure that your 0 is in between those 2 lines. Because if it's not, they're not going to spit out the answer for you, okay? So even if you went from 0 to 3 or 0 to 2, as long as that x-intercept is in between, you're going to get an answer, okay? Now for guess, it doesn't matter. So as long as you have an interval where the 0 is in between, you're always going to get the answer, okay? So for guess, it doesn't matter. So you don't press anything, you just press enter again. And then if you take a look at the bottom, it says 0, x equals 0.9100076. Okay? So the closest answer that we have here is C. All right? So go ahead and try that one more time just to make sure that you guys are well versed in knowing where to go, okay? So once again, I would try this again. So go ahead and hit graph. So how do we get to calculating? We go to second, trace. We're calculating 0, so we're going to press the number 2. And then they're going to ask you 3 questions, left, right, and to guess. You're going to pick a safe number to the left, to the right, and doesn't matter if you guess, just press enter. You know you did it right if the bottom left corner says 0 with the x value. Okay, now, strategically, okay, you're taking this test. You notice on the graph that it's somewhere close to 1. Right away, before you even calculate, you should be able to get rid of some choices. So for instance, no way it's negative 0.46, and no way that it's 0.2, okay? And no way that it's 3.73. It's somewhere close to 1. On your graph, everything is to scale. So you can safely say that it's not 0.2 because that intersection looks like it's closer to 1 than it is 0. Okay? So at least if you happen to forget your calculator functions, you're down to guessing either C or D. 50-50 is not bad at all. Actually, that's really good. Okay? So let's try one. All right? Let's do we're going to jump to number 82 right here. Make sure you're on the right problem. I want you to go ahead and try this on your own. Okay, if you happen to get stuck or if you're done, go ahead and press play, okay? Okay, so here they gave us the F prime hat, so that's what I'm wearing. They want us to find local max, that's our buzzword. Okay, so I'm going to type this out carefully. The square root, so second x squared, x to the fourth. So you're going to use that caret that's right above the divide button. X to the 4, make sure you jump down, plus 1. After you type out plus 1, you have to press the right arrow to jump out of the square root. Okay, plus x to the third, jump down, minus 3x. 99% of the time, people get things wrong because they don't type it out correctly. So just take your time with that, all right? Okay, so we're going to go ahead and hit graph. Okay, just to make sure you're following along, you should have a picture that kind of looks like this, give or take. Okay, so here I have 3 zeros. We're looking for a local max. You guys have to remember that a local max occurs when f prime changes from positive to negative. So in this case, we're looking at this point right here. These are not local maxes because those are changing from negative to positive, okay? So make sure you guys understand that. Okay, so now that we know what we're looking for, we just need to calculate that 0. So we go to second, trace. We're calculating 0, so I'm pressing number 2. That 0 looks like it's somewhere in between 0 and 1. So that's a good safe left and right bound. So I'm going to press 0. You can even press -1 if you guys wanted to, okay? 0 and 1. Before you click enter for guess, confirm that your 0 is somewhere between your 2 dotted lines. And it is. You don't have to guess, just press enter again. And you should get 0. It should physically say 0, okay? X equals 0.350137.5. Okay, so here's the thing. Here's what a lot of people do. So if you guys can hit graph again, okay? So you should only see the picture. You shouldn't see any values. The moment you press up, down, left, or right arrow, you start seeing numbers. A lot of people will try to move that cursor over to where it kind of hits the x-axis. Okay? Now the thing is, if you hover over it, you're either at 0.37878, yada, 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 or you're at 0.30303. Just because it looks like you're on the 0 doesn't mean you are on the 0. These are just approximations. If you want the exact answer, you have to calculate it. In order to calculate it, you have to go to second trace. So don't just go moving your cursor. That's not going to work out. All right? Okay, so there we go. Our answer is C. Okay, now if we were to be strategic about it, process of elimination, since it's somewhere between 0 and 1, I could cross out A, B, and E. And actually, if you stare at this long enough, if you look at that 0, it's closer to 0 than it is to 1. So you could probably even cross out D here without even calculating. Okay? Remember, when you're graphing on a calculator, everything is to scale, so you can actually take advantage of that. All right? Okay. So let's do... Let's do number 82. Okay. Okay, so the derivative of the function f is given by the derivative f prime of x equals x cubed minus 4 sine of x squared plus the 1 on the interval from negative 2.5 to 2.5. At which of the following values does f have a relative maximum? Okay. Now, when you're taking a test, you're skimming through this and you're looking for the buzzword. Here it is, relative max. Okay. You're still wearing the same f prime hat. Okay, so it's easy. So here we go. We're going to go to y equals, so upper left button. Let me move that down. No, that's not it. Let me pick this. Wait, let me erase this. Maybe that's why. There we go. Copy. Just so you guys can follow along with me, okay? All right, here we go. So make sure you guys clear your Y1 and go ahead and type this one out here. It's X, so the variable button, caret 3, jump down, minus 4, sine X squared, parentheses, plus 1. Okay, now if you guys hit graph, I will attempt to draw this. Here we go. You should get something that kind of looks like this. Okay? Now, they tell you where to focus. This interval right here. Okay? Negative 2.5 and 2.5. That is the x value here. That's pretty much saying change your x min to negative 2.5 and change your x max to 2.5. Okay? So what we're going to do here before we calculate anything, we're going to go to Window, which is that second button right here. And you're going to change x min to negative 2.5. Now, don't use the minus sign, okay? Use the negative symbol, which is right underneath the 3. So negative 2.5. Maximum for x should be 2.5. You don't touch the y's, okay? So you're only changing 2 values on your window. You're going to go ahead and hit graph. Okay, so all we're doing is we're shortening the window so that we could focus just on what we want to look at. Okay, so here it is again with relative max. Okay, if you have this sketched out, think about where that relative max is. Pause, think about it, press play whenever you're ready. F has a relative max whenever the derivative changes from positive to negative. So it happens to be this guy right here in green. That is my local max. Okay. Wait a second. Am I looking at this right? Okay, yeah, I guess. All right. So if you notice, in this picture, we only have one relative max. Right? So the only choice we have here is E. Because that's only one of them. Part D and Part B have, Part A, B, and D have two of them. And Part C has 3. So we actually didn't even have to calculate, but for the sake of practicing, go ahead and calculate that 0 there. Remember, we go to second, trace, 2. 0 is a safe number for the left bound, enter. 1 is a safe bound for the right. Doesn't matter if we guess. Yeah, and I got 0 as 0.542. There you have it. Okay? So sometimes, just by understanding what the graph interprets, you could actually rule out a lot of the choices. I didn't actually have to calculate this one. Okay? Cool. Let's do 83 here. All right? Okay, so here we have the derivative. They give you a little window, and they're looking for a relative max. Okay, try this one out here. And play whenever you're ready or if you get stuck, okay? Okay, here we go. Y equals. So first off, most of you will probably get stuck just getting the right graph here, okay? You got to make sure that when there's a lot of stuff going on in the numerator and the denominator, that you group it, okay? Because the calculator is kind of dumb in that sense. So parentheses, x to the third, we jump down, minus 8x squared plus the 3, close it, divided by the square root of x to the third plus the 1, and then I close it, okay? Okay, so I'm going to go ahead and hit graph. Now remember that we changed the window from before. So here's what I want you guys to do. To go back to quote-unquote normal, you're just going to press zoom 6. That's to go back to your default window. So if you press zoom 6, it goes from -10 to 10 on both ends. This is just to make sure that everyone's on the same page, okay? So you should have a graph that looks something like this, okay? But keep in mind that they tell you to fix your window here. Your x minimum should be -1 and your x max should be 9. So let's go ahead and do that. Let's go to window. Remember, use the negative button, -1, and x max should be 9. Everything else we leave alone. Hit graph again, and we have a clearer picture, okay? Okay, so again, they keep using relative max here for some reason. Okay, local max is where the derivative changes from positive to negative. So it's looking like it's this 0 right here. It's not always the middle one, you guys. It just happens to be a coincidence, okay? So now that you know that that's the local max, you just have to calculate it. How do we do that, right? So strategically, this 0 looks like it's somewhere between 0 and 1. So I could actually rule out that it's C, okay? I could rule out A, B, and D, so the only choice left here is C. But let's confirm it, okay? So how do we find the zeros? We go to second, trace, 2. A safe left bound is 0. A safe right bound is 1. Now, it's not always 0 and 1, you guys. You're trying to pick a value that will surround that x-intercept, okay? Doesn't matter if you guess, and we get about 0.63837118, which is this one right here. Okay, so if you take a look, none of it requires work, just analysis, meaning you just have to stare at it and you have to know what they're asking for. And if you know what they're asking for, you can tell the calculator to find it for you. Okay, it's that easy. All right, let's do a couple more that are a little bit different. Let's go back to the beginning of our packet here. Okay, let's do number 77 on the upper right. To make sure that we're all on the same page, go ahead and press zoom 6 so that we fix our window. And let's go to y equals and clear out that function. Or if you want, just reset the whole calculator. I'll give you guys a second to do that. Okay, so number 77. The graph of the function y equals changes concavity at. Okay. So they give us y, which is the function. And we want to know where it changes concavity. Okay? So another word for changing concavity is the point of inflection. Okay? So the thing is, there's a point of inflection, right? When certain things happen. Either f can change concavity, f prime can change directions, or f double prime can change signs. Out of these three here, which one is the easiest to spot? Think about that Press play when you're ready. Okay, so the easiest one to spot is where a sign changes. Okay, because that's pretty much our zero, our x-intercept, our roots. So we wouldn't want to use f because if we're looking at f, it's really hard to see where f changes concavity. Like, it's really tough to calculate that point right there. Okay, but it's very simple to look at the second derivative and see where they change the signs, because that's basically where your zeros are. Okay, so here we go. What we want to do here is we're currently wearing the y hat or the f hat, okay? But we can switch our hats, okay? We can stare at f double prime, and instead of changing concavity, we're going to see where f double prime changes signs, okay? Because a calculator can quickly do that. So here's the thing. For your y1, you're going to type your original function, okay, which is everything in yellow right here. So x to the third, push down, plus 6, x squared, plus 7x, minus the 2 cosine x, okay? So if you hit graph, just to make sure we're typing it in correctly, you guys should have something that looks like this. This is our f, our original function, okay? What we want to do is we want to look at the f double prime graph because it's easy to look at where the sign changes. So go back to y equals, and here's where stuff is new, okay? You're going to press down to y2, okay? So take a look here. You're going to go here often, all right? You're going to press math, okay? And if you look at the numbers, okay? You look at the number 8. It says n deriv. That's short for derivative, okay? You could toggle down to 8, but the easiest thing to do is press math 8, okay? So here's the thing. If you have the newer calculators, it should say d over d blank with a couple of other blanks. Okay? Now, if you have n deriv in a parentheses, oh gosh, I encourage you to go to the library and get a newer calculator. Okay? There is a way to actually do it with the older calculator. It's just not efficient. Okay? Now, if you're really curious about how you want to do that, just text me and I'll show you. Okay? But I'm going to save that from the video. Okay, so here we go. So you press math 8. In front of you, it says y2 equals d over d. You're just going to press your variable button. So it should say d over dx now. Okay, and now you're going to take the derivative of your function, of your what you just had earlier, x cubed plus 6x squared plus 7x minus 2x, minus 2 cosine x. But that's a lot to type. Okay, if only there was a shorter way to just kind of copy paste that. Okay, so here's the second thing that you guys are learning. Okay, if you want to take the derivative of the other function, y1, you're going to go to alpha trace. When you go to alpha trace, there's a little window that pops up. It says y_var. And we want to take the derivative of whatever y1 is. So I'm going to press 1. Go ahead and practice that before you move on. Okay? And then there's the evaluated bar, that vertical bar, x equals. Now, when you're graphing, you guys, okay, it's always x equals x. So put in another variable there. Okay? Now, y2 represents our first derivative. Okay? You can go ahead and hit on graph so you can take a look. Hopefully it pops up. Yeah, it takes a little bit of time because it's calculating the derivative. You should get like a red parabola, or not a red parabola, but a parabola. But that represents the first derivative. We want the second derivative. How do you guys suppose we do that, right? Okay. Now, we would just have to go to y3, okay? And we're just going to take the derivative of the derivative. So again, how do we get to the derivative? Think about that. Press play when you're ready, okay? So to get to the derivative, again, is math 8. Okay, it should give you d over d something. We're going to put d over dx. And we're going to take the derivative of our derivative, which is y2. So the shortcut there is to go to alpha, trace. In this case, we're going to press 2 now for y2. X equals x. Okay, go ahead and hit graph. This might take a while, but I'm trying to prove a point. So if you have the colored ones, it'll be very easy to tell which one's which. If you have the black and white version, don't worry about it. There's a way to kind of filter through it. Oh man, this takes forever. Right, there's this line that's coming up. Okay, so once that eventually happens, right? So something to notice, if it's stuck, a way to troubleshoot that is to press second and on. It turns off the calculation because sometimes you might have mistyped something and you don't want to wait there until it's done. Okay, so here we go. I'm going to press second on just to turn the calculations off. I'm going to go back to y equals. Okay, so once you press y equals, your blinking cursor should be on the x of y1. If you press left, you're hovering right over the equal sign. If you press enter right there, it will unbold the equal sign. You're telling the calculator, do not graph it. Okay? I'm going to go down to y2 over the equal sign and press enter because I don't want to see the function. I don't want to see the f prime. I just want to see f double prime. So the only thing that's bold right now is y3. I'm going to go ahead and hit graph one more time. It might speed up the process. We'll see. And just so you guys know, I'm doing this in real time, so this is how long it takes for that to actually calculate. Okay, so while we wait for that, remember, the graph of the function changes concavity at. We're looking at where the second derivative changes signs. And we can tell that it changes signs because it crosses through the x-axis here. We call that a 0. Okay? Isn't there a way to calculate a 0? Okay, we went over that. But let's be strategic about this, okay? That 0 looks like it's somewhere close to -2. Okay, but a little bit before -2. So I can cross out E, and I can cross out A, B, and possibly even C. Okay, because it's closer to the -2 than it is at the halfway point. So if you had no idea how to calculate it, you could at least guess that it was D here. But let's go ahead and confirm. Go ahead and calculate it. Press play whenever you're ready, or if you forgot how to punch in the buttons, follow along with me now, okay? We're going to go to second, trace, 2 for 0. Easy left bound here. A left number is -3 or -4. It doesn't matter. A safe number to the right is -1, 0, 1, 2, 3, 4, 5. It doesn't matter. And it doesn't matter if you guess, just press enter. You should get negative 1.8941, which is D. Okay, now if you didn't get that, or if you didn't get any of these values, please text me, because it most likely is just a calculator issue that we need to fix, okay? All right, here we go. Let's do... Okay, let's do number 80. Go ahead and try that on your own. Press play whenever you're ready, okay? Okay, here we have the function. I'm going to go ahead and quickly type that out. Cosine 2x for y1. Close it, plus the natural log of 3x. Close it. What's the least value of x, where f changes concavity? Okay, so if we want to change concavity, the easiest way to check on a calculator is where the second derivative changes signs. So I'm going to set up my y2 as the first derivative. So math 8, d over dx, alpha trace for y1, x equals x. And I'm going to go ahead and set up my second derivative, d over dx, alpha trace y2, x equals x. Now, I actually cleared everything so that I could practice it, and you guys should too. I only want to see the second derivative, so I'm going to uncheck y1 and y2. And let's go ahead and hit graph. I'll give you a picture here just to make sure you guys are on the right track. You got something that looks like... This calculator is so slow, it's awesome. Okay, so it was something like this, okay? So f changes concavity whenever the second derivative changes signs. But the issue here is the second derivative changes signs in a lot of places, okay? But if you read, it says, what is the least value? So the smallest value would be that very first 0, which looks like it's at about 1. So I could cross out A, B, D, and E, okay? Some people might argue that it may be B, so you know what? Let me get rid of that. It could be B or C, but let's calculate it. Okay, so we go to second trace. 2, a safe number is either 0 or negative 1 or negative 2. Now, you don't want to include too many zeros in your interval, because then it won't know which one to calculate. So I am going to put the right bound as 2 here so that I don't include the one right after it, okay? So if you guess, you should get... No sign change. That is so weird. Let me know if you guys are getting the same thing here. Second trace, 2, 0, 2. I guess my cursor was somewhere on the outside, so it didn't show. Maybe. Okay, there you go. So the 0 should be 0.931. Oh, good thing that I didn't cross out B there. So, good, B. All right, hopefully you got that too. If you didn't, just let me know. So, hopefully you guys are getting the point here. I'm going to do the rest quickly just so that you guys can get an idea of what we're doing. Oh, here's a new one. Okay. Something new. So the graph of y equals e to the tan x minus 2 crosses the x-axis at one point in the interval from 0 to 1. What is the slope of the graph at this point? Buzzword here is, what is the slope of the graph at this point? Okay? So a few things, make sure that you guys are clearing everything. Okay, clear your y1, your y2, and your y3. I am going to type a y1 equals e to the tan x minus the 2. Okay, make sure the minus 2 is down below and not up in the exponent. Okay, so it says that this graph crosses the x-axis, aka 0, at one point somewhere between 0 and 1. That right there is your x-min and your x-max. So before you hit graph, go ahead and click window. We're going to put x-min as 0 and x-max as 1. Everything else will leave. We're going to hit graph. Okay, so you get a very non-entertaining graph that looks like this. Okay, but there is a 0, which is what we're looking for. Okay, how do we find this 0? Okay, so we go to second, trace, 2, and a safe left bound and a right bound. Think about what that would be. I use 0 and 1 as the left and right bound. Okay, so the 0 on your screen, if you did it correctly, it should say x equals 0 0.606, yada, yada, yada. Okay, actually I should do yada, yada, yada in this one. 1119. Okay, here's the thing though. Did they ask us for the 0? Okay, the ultimate question is, what is the slope of the graph at this point? Okay, so we have to find out what the derivative is at this value. So here's what you guys do. There are a lot of layers to this part here, so make sure that you guys play this many times, okay? Two things. You can either write down 0.6061119 on your paper, or there's a way to kind of copy and paste that, okay? So what you would do is right now you would go to second mode, which is the button right to the right of the second button, second mode. So that goes to your home screen. You know you're at your home screen when everything is blank. Okay? So if you take a look at, let me copy this one more time. If you take a look at right above the on button, stow, that stands for store. It's kind of like copy, okay? If you press store right now, it says answer arrow, okay? You can go ahead and allocate a variable that will represent that 0.6061119 or whatever it was, okay? So if you take a look at your calculator, alpha on my calculator is green. And throughout the whole calculator, there are green letters. You may have a different color, okay? I'm going to press alpha, and then A, enter. So all I did was I pressed alpha, then A. So right now, the calculator will remember that every time I press A, it will represent 0.6061119,347. Okay? Okay, so we want to find the slope of the graph. What does the slope of the graph at this point mean? Okay, pause there, think about what that means. That right there is just fancy for derivative. Okay, so here's what we do. We're still at our home screen. So we're going to calculate the derivative. So we're going to go to Math 8 for derivative. So this will be d over dx always. And we're going to take the derivative of our function. Now, remember, when we were at our y equals, we already established what y1 was. So we could still use y1 here, even though we're in the home screen. So we're going to go to alpha, trace y1. Okay, evaluate it at x equals. So the thing is, when you're graphing, it's always x equals x. Okay, when you're at your home screen, it should always be x equals some number. We want to find the slope at this point. What point are we talking about? We're talking about the point at where it crosses the x-axis, which is our 0. Well, what's the value of our 0? 0.606119. Okay? So you have two options here. You could either type out 0.6061119, or you can just put alpha A if you stored it. Okay? So if you already told the calculator that that value will represent a letter, you could use that letter instead. This saves a lot of time later. Okay? You might not see a lot of value in this now, but you will see it later. Okay? So if you did it right, it should look like d over dx of y1 evaluated at x equals either a or 0.606119. Do not round early. For instance, if you put 0.606 and you round it early, it could throw off the final answer. Okay? Don't round intermediate answers, round only the final answer. You should get about 2.961 if you round it correctly, okay? So there you go. All right. I think I have time for, I don't want to make this video too long. Okay, let me erase this. Let me get rid of this. Okay, we did that. Okay. Actually, I think I'll be able to finish. All right, number 84. For x is somewhere in between negative 1.5 and positive 1.5, let f be the function where the first derivative is all that. Which of the following intervals on which the graph of f is concave down? Okay. Again, with concavity, it's easier to look at the second derivative because when you look at sines, it's easier. When you're trying to look at curvature or where it turns, it's going to be tougher. So here's what we do. Okay. Go ahead and go to your y equals. Okay. Clear out your y1. And go ahead and type out the derivative here. That's going to be e to the parentheses x to the fourth, jump down, minus 2x squared plus the 1, close it, jump down to the floor, minus 2. Make sure that minus 2 is not floating in the exponents, okay? Just to check in with you guys, if you did it right, oh, we forgot to change our window. Okay, so I'm going to go ahead and click on Zoom 6 just to make sure that everyone is having the same picture as I am, and then we'll fix it later. You should have something that kind of looks like this, like a W, okay? Okay, so if you have that, move on. If not, text me or consult with peers here, okay? So here you notice that they give you a window. They tell you what the x min and the x max is. So I'm going to go to window here, type in negative 1.5 for the minimum and 1.5 for the x maximum. Everything else you leave alone. Hit graph one more time. You should get something that looks like that, because it's focusing in on an area. Okay, so where is the function concave down? Okay, a function is concave down when f double prime, go back and check if you need to, press play when you're ready. F is concave down implies that f double prime is negative, meaning below the x-axis, if you're looking at the second derivative graph here, okay? So I'll actually color it. So the second derivative is negative from here to here, from here to here. I noticed that there are two intervals. So right away, I could cross out A and B and even C because they have either one interval or three intervals. We know it has to be two. Okay. Could I eyeball this? Yeah, I could even rule out D, because if you take a look at the second interval, it doesn't look like it starts from 0 to 1. It looks like it starts from 0 point something to 1 point something. So from there, we could understand that it's C, but let me show you guys how to calculate this here. What you would do is, we have 4 zeros here. Usually just checking one will do. I'm going to go ahead and check this one. All right, so let's go to second, trace 0. Left bound, I'll put 0. Right bound, I'll put 1. You should get 0.4092009. That should be enough for you to pick C. You don't have to check all of them. That's just a waste of time if you do. Okay? So again, you know, there's that calculator perspective, but also process of elimination that you guys don't want to forget. All right? Okay. Let's do number 80 here. Okay, press play whenever you're ready. Okay, here they gave us f prime, so I'm going to type that out, x to the fourth minus 6x squared minus 8x minus 3. I want to know where the function is concave up, so I'm going to go to the second derivative so I can see where it's positive, okay? So I'm going to graph the second derivative. Wait, hang on. Wait a second. Did I do that one wrong? Let me go back and check. So e to the x to the 4. I think I might have just looked at the first derivative graph instead of the second derivative graph. Let me double check. Yeah, okay. Rewind. Here we go. Come on, Mr. Lee. What's wrong with you? Okay. This graph right here, why did I label it as f double prime? So this right here is actually f prime. We want to get to the second derivative. So we're going to go back to y equals and go to y2 and graph our second derivative. So we go to math 8, alpha trace for our y1, and x equals x as always. I'm going to uncheck y1 so I don't look at it. Ooh, good thing I didn't. Ooh, okay. Mr. Lee slipping. Okay, so if you graph the second derivative, it should look like this. Okay, let's try this one more time. Okay, so here is the second derivative, and the second derivative is negative whenever the second derivative is below the x-axis. Okay, so here we notice that it's 2 intervals. So again, I can cross out A, B, and E. And actually, it is going from 0 to 1 here. It looks like it's going from 0 to 1, so the more appropriate answer is D. So they actually threw this in just to make sure that you're graphing the right one. Okay, so again, whoops. Okay, let's try this one. Okay, so here we go. We have x to the fourth minus 6x squared minus 8x minus the 3. That's just our first derivative, so I'm going to go ahead and graph the second derivative. So math 8, alpha trace y1, x equals x. I'm only going to want to see y2, so I'm going to uncheck y1. I'll go back to zoom 6 because there's no interval here. Okay, so the graph looks a little bit like this. Okay, where's the graph concave up? Wherever the second derivative is positive, so pretty much wherever the second derivative is above the x-axis. Okay, it's looking like it's something to infinity, so it's not going to be C or D. And it's definitely not 0, okay, because we're looking at the x values. It starts at 2, so it's going to be A. All right. I got to squeeze in this last one, okay? All right, last one for the day. A particle moves along the x-axis so that its velocity is v of t equals all that. What is the acceleration at t equals 6? So here we're talking about particle motion. That's v. They're asking for acceleration. So remember, it's position, salted, very, almonds. So acceleration is pretty much just the derivative of v. Okay, and we want to find the acceleration at t equals 6. So here we go. We're going to go to our y equals. Let's clear everything. We're going to type in v of t, which is t squared. Now it says t here, but you could just use the variable x. It doesn't matter. X squared times the natural log of x plus 2. Close it. And then I'm going to go to quit. Okay, I'm going to go to second mode because I'm trying to evaluate something. I want to find the acceleration, so that's the derivative. So I'm going to go to math 8. So we're going to do d over dx of y1, which is alpha trace, okay, evaluated. Now, where do I want to find the acceleration? At t equals 6. So I'm going to put 6 there, and you should get 29.453. It's a simple plug and chug. Very simple question to get. I'll leave that for you guys to do, but do text me if you guys have questions, okay? On Delta Math, you guys are going to be practicing questions just like these, so make sure that you have your calculator ready, okay? Text me if you guys have questions.